Welcome to this Any Excuse for a Chemistry Experiment video. If you're doing your chemistry GCSEs, there is a good chance that this required practical will come up or the science behind it. We're going to be looking at investigating the variables that affect temperature changes in reacting solutions. We'll go through the experiment, scientific principles and the exam style questions. Feel free to jump to the bit that you need or watch it through. To be confident with this required practical, we must be confident with the procedure, recording the data and interpreting the data. If we keep this in mind, we'll be okay. This required practical usually involves 4 separate experiments. The first one, an acid plus an alkali. Second one, an acid plus a metal. Third one is an acid plus a metal carbonate. The fourth one is a displacement reaction of a soluble salt with a more reactive metal. Some prior revision of your neutralization could be useful at this point. In each experiment, at least one of the reactants will be a solution. Experiment 1. We'll need to be confident with the names of the equipment and the procedure. The equipment for experiment 1, the neutralization of an acid with an alkali, we're going to need a polystyrene cup, 250ml beaker, a burette, a temperature probe, 1 molar hydrochloric acid, 1 molar sodium hydroxide, and a 50 centimetre cubed measuring cylinder. Stand the polystyrene cup in the 250ml beaker for stability. Measure 40 centimetre cubed of sodium hydroxide with the measuring cylinder. Pour the sodium hydroxide into the polystyrene cup. Fill the burette with hydrochloric acid. Measure the start temperature of the sodium hydroxide until the temperature doesn't change. Record the temperature in a results table. Add 5 centimetres cubed of acid from the burette. Stir and record the temperature. Repeat this until you add 40 centimetres cubed of the acid. Experiments 2, 3 and 4. The equipment that we're going to need is the same. Remember, we've got to be confident with the names of the equipment and the procedure. The equipment is going to be the polystyrene cup and lid this time, 25ml beaker, spatula, temperature probe, stopwatch, 25 centimetre cubed measuring cylinder, 1 molar hydrochloric acid, calcium sulfate solution, zinc powder, magnesium powder and powdered calcium carbonate. Experiment 2. Stand the polystyrene cup in the 250ml beaker for stability. Measure the 20 centimetres cubed of the acid and pour it into the beaker. Place the lid on the cup with the temperature probe in the acid. Record the temperature once it remains constant. Add a level spatula of magnesium powder. Stir continuously. Record the temperature every 30 seconds for 5 minutes. Experiment 3. Set up the experiment as before. Measure and record the start temperature of the acid. Add 1 spatula of the calcium carbonate. Stir and record the temperature. Remember to replace the lid. Repeat with another level spatula of calcium carbonate. Repeat until you've added 5 level spatulas. Record the temperature each time. Experiment 4. Stand the polystyrene cup in the 250ml beaker, measure 20 centimetre cubed of copper sulphate solution this time, pour it into the cup. Measure and record the start temperature. Add a level spatula of zinc powder, replace the lid, stir continuously, record the temperature every 30 seconds for 5 minutes. Once that's finished, we can repeat the same experiment, but this time using magnesium powder. We're looking for the maximum temperature change. Let's have a closer look at the science. When a reaction takes place, energy is transferred. If the reaction gets hotter, we can say that the reaction is exothermic. Energy is being released. If the reaction gets colder, we can say the reaction is endothermic. Energy is being absorbed. If the reaction is taking place in a solution, we can measure the temperature change of that solution. We can calculate the energy transferred by using the specific heat capacity equation. We need to know the mass of the solution. We'll get told this or how to work it out. We assume that all solutions have a mass of 1 gram per centimetre cubed. So 40 centimetres cubed will have a mass of 40 grams. We need the specific heat capacity value for our solution. We make a second assumption here. All solutions have the same specific heat capacity as water, 4.2 joules per gram per degree Celsius. You'll get told this as part of the exam question. We need to know the maximum temperature change that occurs. Subtract the start temperature from the end temperature. We use the symbol delta T in our equation. If the temperature goes up, this will be a positive value. If the temperature goes down, it will be a negative value. We now use the specific heat capacity equation. Q is equal to mc delta T. Exam tips section. I've seen 3 types of questions for this required practical. The how can I improve on this method question. The student completes the experiment using the equipment in the diagram. Suggest how they could improve their results. The calculate the mean average of the results question. Calculating a mean average, you must take into account the anomalous results. The is the reaction exothermic or endothermic question. Describe the energy changes in the reaction. Explain your answer using changes in bond energy. The first question requires you to analyse the image and look for any improvements. The usual improvements will include the addition of some insulation. Have they used a polystyrene cup? Is there a lid? Other improvements might include stirring continuously. You need to ensure the reactants react as quickly as possible. The second question requires a little bravery on your behalf. You will need to look at the pattern of results. Estimate the difference between the results. Usually there'll be only a few units difference between most of them. If you spot one result that is significantly bigger or significantly smaller than the rest, cross it out, circle it, highlight it, but ignore it when you do your mean calculation results. Question 3 wants you to apply the results to your energy changes knowledge. If the temperature goes up, the reaction is exothermic. If the temperature goes down, the reaction is endothermic. The explanation requires you to state the energy is needed to break the bond of the reactants, then energy is released when new bonds form. If it's exothermic, you release more energy than you take in. If the reaction is endothermic, you require more energy to break the bonds than is released when new bonds form. This required practical needs you to be confident with your practical skills. Look for the revision questions that include anomalous results. Make a mental note of how different they are from the other results. Thank you for viewing this video. I'll post all the required practicals on this playlist. If you found it useful, please subscribe. Click the thumbs up button. Look out for more videos to help you with your GCSE chemistry. Thank you and goodbye.